Did you know it was not a landslide but a particular gas which led to the accident in the Sikkim Tunnel?
According to officials, the gas may have naturally escaped from underground rock formations disturbed by the landslide.
Why methane led to such a fatal accident, and why are we not learning from the recurring pattern of such accidents, especially in the Himalayan region? Hello everyone, welcome to Vajiram and Ravi's Flash News. My name is Shubhangi Singh, and in today's session we are not just going to speak that Sikkim Samardung Tunnel accident happened. We are going to understand the exact cause behind it, and more importantly that why are we not learning from these incidents, be it Silkyara in 2023 and now in 2026 Sikkim Tunnel Collapse has happened. And furthermore, we will be also looking into understanding that when we are talking about development, especially in Himalayan regions which are fragile, why are we missing out certain important pointers? So let us begin with understanding that what exactly has happened. So the incident has taken place in an under construction Samardung Tunnel, which is located in the Namchi district in Sikkim. Now when we are talking about this tunnel, this is part of a bigger project which is NHPC's Teesta stage 6th hydroelectric project. Now this tunnel is part of this very hydroelectric project. Now when the tunnel collapse happened, which as of now unfortunately has taken already more than 20 lives, many are yet to be found and there is no confirmation also on the death count. So in this context, initially it was suspected that this collapse has happened because of landslide. Later it was understood that it was not the landslide, rather this collapse and the accident was triggered by a methane gas explosion that happened in this very tunnel. Now for two reasons, understanding this accident in detail becomes very important, because this is yet another a major infrastructure accident in our country where infrastructure accidents are very common. Second, we also have to understand that this is a very rare case of gas-induced tunnel collapse. So this is something that should come as a learning for us, that probes us into better geological investigation, that makes us focus better on workers' safety, gas monitoring problems and the systems which can facilitate it. And most importantly, the emergency preparedness if emergencies and disasters occur. If the disasters occur, especially when we are talking about the fragile Himalayan region where the accessibility is difficult, resources are difficult and so many factors. So we will be moving to the discussion about infrastructure around Himalayan region gradually. First, let us understand that how did the methane cause the disaster. For this, let us try to understand the sequence of events. That means what exactly happened and how it led to a domino effect. Now in this context, we are going to talk about methane, which is a odorless, colorless gas, goes by the formula, very simple formula. Achha, okay, then I'll let you guess this formula. Very simple, basic formula. But the one thing that you have to remember, let me know the formula in the comment section. One thing you have to remember that this has the capability to displace oxygen, which leads to suffocation. Now this accident began with when the tunnel excavation was taking place. One of the rock which were bearing methane, they were excavated and they were broken down. Now this led to methane escaping rapidly into the tunnel, and the tunnel was a confined space. And then probably an ignition source, maybe an electric socket, circuit or something around triggered the explosion. Now it was probably fire and expanding gas which injured the workers, and then the oxygen levels dropped so rapidly and high methane concentration prevented any type of immediate rescue, and the oxygen dropping levels were so difficult to manage that the escape was also not possible. So in this whole situation, we clearly understand that the cause and the killing point here is methane. Because when we are talking about methane, it is a dangerous gas. Not just because it displaces oxygen, but also because of the fact the explosion range of methane is high, 5 to 15% in air. Then it acts as a asphyxant, and as I said, it is odorless, it is colorless, so it is very difficult to detect it at all. Now, another factor that we have to understand that makes methane one of the most dangerous gases out there, that it can easily ignite with very small sparks as well. And all of these factors are responsible for the tragedy that we are seeing in the Samardung Sikkim Tunnel. But when we are looking at methane-rich geological formations, this is something that can take place. But there are international safety practices to ensure that such accidents do not happen, with very important engineering controls, such as continuous gas monitoring, such as explosion-proof electric setup, emergency evacuation plans, proper geological mapping when we are talking about excavation and understanding the threat. But as of now, these engineering controls, especially in the informal setup, the limited tools, the limited resources that we are talking about, and especially the carelessness with which government operates in terms of contracting, the money that is being paid, a lot of factors, these international safety practices probably did not materialize right here. And that is why whatever happened has amplified the number of deaths that we are seeing today. Now, this is exactly where we also have to understand that it is very important to focus on safety practices, but it is more important to focus on other factors, especially when we are dealing with a very sensitive region. That is the whole Himalayan region. And if we are talking about Himalayan infrastructure, it needs Himalayan solutions as well. And this is something that we have not seen today also, we have seen in 2023 as well, where a tunnel collapse led to trapping of 41 workers which were released after 17 days, rescued after 17 days. And this repeated incidents clearly show us that when we are talking about Himalayan tunnels, there are certain challenges not just related to rescue, but across the infrastructure safety as well. Now, when I am comparing these two incidents, I am not saying that they have happened because of the same causes or same factors. There are different factors which are involved, but at the same time, we have to look into the fact that it is the fragile Himalayan geology that we are talking about. And the second thing that you will find common here, that how questions are being raised about safety audits here and how questions are being raised over gas monitoring, if I have to term it in a broader way, the engineering controls which could have operated as safety gear. Now, in this context, the first thing that we need to focus on is the fragile Himalayan geology. Why are we saying that this is fragile? Let us understand the characteristics first. Because these characteristics will tell you that why Himalayan construction is different. Himalayan construction is very different because we are talking about young fold mountains which are present here. We are talking about active tectonic movement. We are talking about frequent landslide. We are talking about high seismicity. We are talking about fault zones, water ingress, variable rock strength, and also that there is no predictability that where gas pockets might be lying when we are talking about the underground excavation. So this is what makes the Himalayan construction so different and also tells you how come this region is extremely fragile. So this uncertainty, the difference, the fragility requires better adaptive engineering, continuous monitoring and basic deliverables on safety standards. And unfortunately, as of now, it seems that we are failing on that. And that is why I want to question here, I'll answer as well, that why are we not learning from all of this? Why did we not understand that how difficult is development in such fragile regions? Why are we asking for development on the cost of, why the government is going for development on the cost of human lives, on the cost of environment, on the cost of so many societal, economical, environmental factors which cannot be compensated in form of ex gratia or anything that has been announced by the government. Now, when we are talking about why we are not learning, this is a very broad question, but at the same time I would like to address it here. First thing, that our mentality and most broadly as a country, we have been okay with the reactive way instead of preventive way. Even though we have talked about prevention is better than cure, but we focus on putting things right once they have gone wrong. And especially in a fractured system that we see in front of us, this reactive way is also not working out too well for us. To state it simply, investigations start after accidents. Hazard identification often remains inadequate. The geological characterization that is required, it is absolute limited, and certain cases it is non-existent. For example, when we are talking about geological surveys, they fully not. So when we are talking about geological surveys, because of technicalities and sometimes because of the other factors as well, they might not capture the gas leaks, the fault zone, rock layer variability and more. This might be related to technology also, the expenditure also, and many other factors. Apart from that, we are lacking in terms of real-time monitoring. We have insufficient deployment of gas sensors. We have insufficient deployment of ground movement centers, AI-based warning systems, and the biggest problem, I have previously discussed it multiple times, is the contractor safety culture. There is extremely minimal cost involved with a very difficult timeline which creates a lot of pressure. So the idea is to get work done no matter what. And amidst this, workers' safety goes for a toss. It is an absolutely inadequate priority in our country. And if we have to put it on institutions are not learning lessons from previous failures, which are not just one. I have taken just one big example. There are multiple, especially when in a country we are building tunnels left, right and center. Atal Tunnel, we have finally cracked a big final end to the Zojila Tunnel and more. This is something that will serve as a very important learning in the upcoming infrastructure, but it seems like we are very poor in terms of institutional learning as well. All in all, it shows that infrastructure, the expansion of it is coming at the cost of lives, at the cost of safety audits, at the cost of worker safety and so much more, which should not be happening. What are your thoughts on this? Let me know in the comment section. I would really like to know, why do you think we are not learning, how we can improve and more. Now let us talk about the way forward. And when we are talking about the way forward and when we are talking about a safer Himalayan infrastructure, it is going to be a multi-dimensional effect coming from all the stakeholders, starting with engineering measures, adding up with geological measures, then polishing it out, furnishing it out with institutional measures and topping it off with a proper policy measure. Now, the reason I have given you the dimensions here, because I want you to tell me in the comment section that what can fit in engineering measures, geological measures, when we are talking about policy measures and also institutional measures. We have discussed them in form of challenges. Now, try to address them in form of way forward. This will give you pointers for mains answer writing as well. In the end, I would just like to conclude on the fact that when we are talking about infrastructure in Himalayas, it cannot follow a plain-based engineering. It needs to be specialized. It needs to understand the intricacies, complications, as well as the fragility of this very region. And then based on that, we can expect the infrastructure development. Now, that was all from my side. I'll be leaving you here with a prelims practice question. Very easy basic question, but important from the perspective of the exam. Let me know the answer to this in the comment section. Thank you so much.